correlation, causation, and scatter plots are an important concept. Usually when we're dealing with correlation and causation and scatter plots, we're dealing with having two different variables. So we're looking for that relationship and strength between those two different variables. Correlation is the strength of the relationship between the two variables. So I do want to point out that a lot of people think correlation is the relationship, and it's not. Correlation is actually the strength of that relationship, how strong it is, how weak it is. And one way to determine the correlation between two variables is to draw a scatter plot. So we're going to go ahead and take an example where we're drawing a scatter plot. So we're looking at a sample of married couples, their ages in years, and we've got the husband's age and we have the wife's age. And this 36 and this 35 belong together. They are an ordered pair that belong together. Same with the 72 and 67 and so forth all the way along the way. So these numbers actually belong together and they are ordered pairs. So the way you create a scatter plot is you make one variable be your x variable and one variable be your y variable. In this case, let's put the husband's on the x variable and the wife's age on the y. And so we've got our husband's age in years along the x-axis, our wife's age in years along the y-axis. Again, you do want to label that. It also would be good to actually put a title on this. So the title could be Married Couples Ages. So make sure you always have titles on all your graphs and you've labeled your axes. So then we're going to plot this. You're going to actually come over here along the x-axis to 36. So make a scale. This one we went 10, 20, 30, 40, 50, 60, 70. Looking at this, we don't have anybody's age above 70. We don't have anybody below 10. So we put that on there. We actually probably could have started at 20, maybe even 30 looking at this data, but it doesn't hurt to go a little bit longer. And the same kind of scale on the y-axis. And then 36, 35 means I come over to 36 and I come up here to 35 and I put a dot. And that's all it is a dot. You're not going to connect the dots, you're just putting the dot. So you're basically plotting ordered pairs. 72 is over here, 67 is way up here, and you see there's your dot. 37, 33, there's that dot. And so forth all along all the dots. So this would be your scatter plot. It looks kind of like, if I were thinking about a relationship here, it looks like I could get kind of a positive relationship because it does look like it's going up. It also looks linear. So there are lots of different relationships in the world. There's a linear line, which would be dots that kind of look like this. There's an exponential, which would be kind of dots that look like this. There is a what we would call a parabolic. So there's that relationship. There are lots of different relationships that exist in the world. There's this one, which kind of looks periodic. And so you want to look at that relationship, and this looks like it's kind of linear, where you could think about a line fitting this data. And it looks like it's fairly, but we're going to worry about the word here in a couple minutes, but let's talk about what kind of relationships we can have. So there are different types of correlation. These are only linear we're going to be dealing with. We're not going to be looking at exponential or quadratic or anything else, but you do need to use the word linear when you're describing that relationship so we know that it actually is a linear relationship and not some other one. Looking at this, if you plot this scatter plot, notice these dots look really close to that line. So we call this one strong. These kind of look kind of a general trend of upward. There seems to be a little bit of not perfectly on a line, but there does seem to be a general trend. So you might call this one moderate. You can also go the other way. So you can have go downward. And again, this looks like a very strong one here. And this one looks like a fairly kind of moderate one. So, but it's negative. So this one was positive strong. This one is strong negative. This one is moderate positive, and this one's moderate negative. You can also have just, the dots just don't seem to form any pattern whatsoever. So we call this one no correlation or low correlation. This one also is not linear. This one actually is quadratic. And so we would say it's nonlinear correlation. There are lots of ways of measuring correlation, um, and the ones we're dealing with are only going to be doing linear, but you can have other ones too. So make sure you use the word linear when you're talking about correlation, because that's kind of the relationship we have. So one thing I want to point out is no correlation. Neither one of these has correlation in terms of a linear correlation, but that does not mean there's no relationship. This one has a relationship. It happens to be quadratic. This one has no relationship. So there are two different things you can think of when we say we have no correlation. These two have no correlation, but that does not mean no relationship. So going back to our graph, this one here looks like there's a fairly good positive and strong linear correlation. So we would call it strong positive linear correlation.